Welcome to Lecture Online, and now let's do one example of how to calculate the current through each of the 4 branches of a 4-branch parallel circuit. We have 17 amps entering the branch point. The top resistor is 2 ohms, then we have a 5 ohm resistor, a 10 ohm resistor, and a 20 ohm resistor. So what we're going to do to make things a little simpler, let's calculate the denominator of each of those 4 fractions. So what we're going to do is multiply R1, R2, and R3. So R1, R2, and R3 together is equal to 2 times 5 times 10, which is 50 times 10, which is equal to 500. Then we have the next one, which is R1, R2, and R4. R1, R2, and R4, which is equal to 2 times 5 times 20. Oh, am I doing this right? No, let's take that back. That's not 500. That's 50 times 2, which is 100. This here is 200. Okay, so next we have R1, R3, R4. R1, R3, R4 is equal to 2 times 10 times 20. That's equal to 400. And finally, we have R2, R3, and R4, which is equal to 5 times 10 times 20, which is equal to 1,000. So you can see that when we add those together, when we sum them together, this will equal to 100 plus 200 plus 400 plus 1,000, which is equal to 1,700. Which means the denominators of each of those 4 fractions will be equal to 1,700. Now we can calculate the individual currents. Starting with I4. I4 will be equal to R1, R2, R3 divided by 1,700, multiply times, of course, the 17 amps, the total current entering the branch point. So the product of the first one will be 100 divided by 1,700 times 17 amps. Notice how carefully I picked the current entering here to make the calculations a little bit easier. So 17 divided by 1,700 is 1 over 100 times 100. That's equal to 1 amp. For I3, this is equal to R1, R2 times R4 divided by 1,700, multiplied times 17 amps. And the numerator here, that will be this one right here, that will be 200 divided by 1,700 times the 17 amps, which in this case would be 2 amps. Calculating I2, that's equal to R1, R3, R4 divided by 1,700, multiplied times 17 amps, which is equal to, that would be 400 divided by 1,700 times 17 amps, which in this case is 4 amps. And finally, getting I1, that's equal to R2, R3, R4 divided by 1,700, multiplied times 17 amps, which is equal to 1,000 divided by 1,700, 1,700, multiplied times 17 amps, which is equal to 10 amps. And then to check, notice that the 4 currents added together should, of course, add up to 17 amps, and you can see that 1 plus 2 plus 4 plus 10 indeed does add up to 17 amps, and so you can see that that's how you find the current in each of the branches if you have 4 branches parallel to one another. And that's how it's done.